Hello. We're now going to go over the practice review for exam 2. The first question asks, how many ways can 5 different television programs be selected from 12 programs? Well, whenever you see the word selected, you're thinking of combinations. So the answer is 12C5, 792, because there's 12 programs and we're selecting 5. How many ways can 7 students be seated in 7 seats? Here we're arranging the 7 students into 7 seats. So it's 7 factorial, which is 5,040. How many different license plate numbers are possible if non-zero digits are used for the 4 leading characters, letters are used for the 3 trailing characters, and letters are not allowed to repeat? Well, remember the digits are 0 through 9, so there's 10 digits, but we're not using 0. So here we're using our multiplication rule, and the non-zero digits are allowed to repeat, so that's going to be 9 times 9 times 9 times 9. And then we have 3 letters. There's 26 letters, but repetitions are not allowed, so you have 26 choices for the first spot, 25 for the second, and 24 for the third. You multiply these out to get 102,351,600. You have 5 places left for stamps in your stamp book, and you have 8 stamps. How many different ways can you arrange? So arrange is permutations, the 5. So it's 8p5, which is 6,720. Right, because it's permutations. When 2 dice are rolled, find the probability of getting a sum greater than 9, a sum of 7, a sum of 5 or 6. So a sum greater than 9 would be a sum of 10, 11, and 12, while there's 6 possibilities out of 36, which reduces to 1/6. A sum of 7, once again, there are 6 possibilities for a sum of 7. You can check your chart that I supplied to you previously, and you should have 6 different ways of getting a sum of 7. 6 out of 36, 1 out of 6. A sum of 5 or 6, well, to get a sum of 6, there's 5 ways. To get a sum of 5, there's 4. So that's going to be 9 out of 36, which reduces to 1/4. A card is drawn from a deck. Find the probability of getting a 7 in the club. And just means that they have something in common. There's only 1 7 of clubs out of 52 cards. To get a 7 or a club, that means we add. So you add the 4 sevens with the 13 clubs, but we subtract out what we overcount. We get 16 out of 52, which reduces to 4 out of 13. A red jack is 2 out of 52. That reduces to 1 out of 26. In a certain geographic region, newspapers are classified as being published daily morning, daily evening, and weekly. Some have a comic sections and some do not. So we have a contingency table. Some have comics, yes, no, and we have morning, evening, and weekly. So remember, the first step is we always want to find the sum of each row and each column. So we're going to add 5, we're going to get 6. 7 and 2 is 9. Let's add the columns. We have 5, 7, and 3. And then the grand total, we'll put that in red. You can either add this column or this row. That should be 15. So it says the newspaper is daily morning, so the daily mornings would be these values here. This row, so that's going to be 5 or has comics, and has comics would be 6. So 5 plus 6 is 11 minus 2, 9 out of 15, which reduces to 3 out of 5. A newspaper is published weekly or does not have comics. Well, weekly, there's 3 weekly magazines. Does not have comics, there's 9. So 9 plus 3 is 12, but we have a 2 that we're overcounting. So 12 minus 2 is 10. So it's 10 out of 15, which reduces to 2 out of 3. Another contingency table. 80 students in the school cafeteria were asked if they favored a ban on smoking in the cafeteria. We have the results in the table here. Now we're looking at a conditional probability, given that a student is a freshman. So we only focus on the freshmen. If we were to add up this row, that's 32 freshmen. He or she opposes the ban. Well, 27 out of the entire sum of the row opposes the ban, so 27 out of 32. Given that the student favors the ban, well, how many people favor the ban? That's 38. The student is a sophomore, so 23 out of 38. Number 9, at a teachers' conference, there were 4 English teachers, 3 math teachers, and 5 science teachers. If 2 teachers are selected at random to be in a committee, find the probability, and here's our key wording here, at least one is a science teacher. Well, whenever we have the at least one wording, we use 1 minus none as a science teacher. So we just compute 1 minus, there's 2 teachers we're selecting, they cannot be science teachers, so there's 7 non-science teachers out of 12 times 6 out of 11. Multiply this out and compute, we get 0.682. If there are 4 cans of cola, 3 cans of lemonade, and 5 cans of iced tea in the cooler, in how many orders is it possible to consume these drinks? Here we have our keyword identical. That means we have repetitions with permutations. So we count up the number of cans, there's 12, and we take 12 factorial. If each can were different, that would be our answer. But we have 4 cans of cola, so we're going to take 4 factorial, 3 cans of lemonade, 3 factorial, 5 cans of iced tea, 5 factorial. Perform our computations to get 27,720. To play the Super Lotto Plus, a player must select 5 numbers from 1 to 47 and 1 number from 1 to 27. How many, they should say, Super Lotto Plus combinations are possible? Well, here we break them up into categories. We have our 1 through 47 numbers, so 47C5, because we're selecting numbers, times our other numbers, 1 through 27, that's 27C1. There's 41,416,353 such combinations. A hand of 3 cards is dealt from a well-shuffled deck. What is the probability that the hand contains the following? No aces, at least 1 ace. Well, no aces, we pick 2 cards. They can't be an ace. There's 4 aces in the deck, so 48 are not aces. 48 out of 52 times 47 out of 51 times 46 out of 50, we get 0.783 when you convert it to a decimal. And then when it says at least 1, once again we're using that other formula. It's 1 minus they're not aces, so 0.217. If there is a 25% chance of receiving a ticket for cruising on Saturday night, we put a Saturday night. Find the probabilities for 3 random drivers that are cruising. All 3 receive a ticket. Well, these are independent events because we're picking a small sample from a large population. So the part A is 0.25 to the third, 0.016. B, none of the 3 receive tickets. Well, first we take 1 minus 0.25 to get 0.75, and we raise that to the third power, 0.422. And then for C, at least 1, once again, it's at least 1. That's always 1 minus none. So it's 1 minus 0.422 to give us 0.578. Find the percentile rank of 350 and 560. The data represents GMAT score. So we have a list of data values. We want to find the percentile for 350. Well, there's only one value that comes before 350. According to our formula, we add it to 0.5, divide by the number of data values. There's 7 times 100, and we round to 21. So it's the 21st percentile. And the same thing with 560. There's 4 values that precede 560. 4 plus 0.5 is 4.5 divided by 7 times 100, round to 64. Now we have a problem where we have to find the values in the 40th and 80th percentiles. Well, we have to compute our C value. That's going to tell us how many spaces to count. N is 7 because we have 7 values times 40 divided by 100. That's 2.78. We round to 3 and we count 3 spaces to get to 430. Using the same formula with 80, 7 times 80 is 560 divided by 100. 5.6 to round to 6, count 6 spaces to get to 720. And here we have a list of data values. We have to find our quartiles, our IQR. We'll just change this to watching an action movie. At a local theater. Well, first of all, we start with Q2. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data values. So to get to Q2, it's just the median, so that's 15. To get Q1, we take the midpoint, because there's 4 data values that precede 15. Take the midpoint of 9 and 10, that's 9.5. To get Q3, we take the midpoint of 21 and 22 to get 21.5. IQR is the difference of Q3 and Q1, so that's 12. And then we use our formulas to compute our 2 fences, left fence negative 8.5, right fence 39.5, and we can see that 78 is larger than 39.5, thus 78 is an outlier. And that's going to conclude our review of, for exam 2. Study hard, people.